Want to take a look at how you can find a linear equation with a table, or how you find a linear function from a table. Of course, a linear equation simply means an equation that can be written as y equal mx plus b. Now that's writing it in equation form. If you choose to write it in function form, you would simply write it as f of x equaling mx plus b. This is really just two different ways of writing the same thing, two different forms for the same type of equation slash function. Now, for a table of values to be able to be represented in a linear fashion, what we have to have is a constant slope. Now, remember, slope can be defined several different ways. It can be expressed as rise over run. It can be expressed as y2 minus y1 over x2 minus x1. But when we're working with a table of values, we typically write it as delta y over delta x, where the delta basically means change in. So for example, with this table we already have, we can come over and we can look at our delta x values first. This first delta x is equal to a change of 1, because it went only from 1 to 2. The next delta x is a 1 also, because it went from 2 to 3. The next delta x will be a 1 as well. Now we look at our delta y's. From 8 to 9.5, that's a delta y of 1.5. From 9.5 to 11, that's a delta y of 1.5. And from 11 to 12.5, that's a delta y of 1.5. Now, we do not have to have all the delta y's being the same. We don't have to have all the delta x's being the same. It turned out that way this time, but that's not what has to happen. What we have to see as we go down the table is the ratio of delta y to delta x needs to turn out to be the same thing every time, which this time that did happen. So for this particular table of values, we see it's linear, because when you take each delta y and divide it by the delta x across from it, each and every time you get 1.5. So that means, whether you want to write this in equation form or function form, we've got f of x equaling 1.5 times x, and the only thing that's missing is the b value. Now you remember, the b represents the y-intercept. Y-intercepts occur when you have an x value of 0. Now, as you can see, there was no x value of 0 on this table. So what we need to do is extrapolate a little bit. In other words, work our way backwards. If we were to, for example, start at 4, x value of 4, we could back it up 1.5 by subtracting 1.5 when we'd be at 11. 11 minus 1.5 is the 9.5. Minus 1.5 again is the 8, and minus 1.5 again will be a positive 6.5. So that is the function that would have created this table. Now let's go over here to the calculator. I've already got a rule in the calculator in the y equal to menu. And we can go through the same process again and find another rule. Alright, this table has x values of 2, 4, 6, and 8. As you can see, as we go along, the delta x is 2 each time. 2 to 4 is a difference of 2. 4 to 6 is a difference of 2. 6 to 8 is a difference of 2. 8 to 10 is a difference of 2. So, we've got our slope being delta y over delta x, and the bottom we already see is a 2. Now for our delta y's, we go 8 to 14, 14 to 20, 20 to 26, 26 to 32. That's a delta y. Every time, same delta y of 6. Again, not that they all have to be the same. It's just that every time we divide them, they have to divide out to be the same. And a delta y of 6 over 2 would be a 3. Another 6 over 2 would be a 3. So we have a slope of 3. So in function form, we've got f of x equaling 3x. And again, we need to back up and see what the zero value would have been. All right, backing up from 8, x value of 8 to x value of 6, we went back to 20, back to 14, back to 8. And to back up one more time would put us back at 0, and we would be at a positive 2. So a 3x plus 2 is the rule, and we can look at it now on the calculator. 3x plus 2 is the rule that created that table of values. So again, remember, if the delta y over delta x is the same every time, not the actual delta x being the same, not the delta y being the same, but the ratio being the same every time, then the equation is linear, and if you find the 0th value, it'll be your slope, and you'll have the rule that describes that table.